Okay, so we're going to look at some probability examples. In this example, I'm going to roll a single die twice and record the first and then the second roll. So this type of problem really is, once you have the sample space generated, you can look at the sample space to get a variety of different answers for probabilities. So first we're going to generate the sample space and then look at the various probability problems that we can ask. So the sample space is the set of all possible outcomes, and we're going to start generating it by filling in the first row here. There's I'm going to have the first die be a 1, and there'd be 6 possibilities for the second die. So we roll a 1 first, and then a 1 second, a 1 first, and a 2 second, 1 first, 3 second, etc. And I'm going to arrange this sort of 6 by 6 table here where I'm putting the row and then the column. The row represents the first die, the column represents the second die. You'll notice this is actually the reverse of Excel, but I did this first and then realized that, so it'll work. So again, we generate the first row, which is the first die is 1, the second die is 1 through 6. Then I do the same thing for the second row, where the first die is a 2, and the second die is 1 through 6. Then I just do that for the rest of the first rows, being 3, 4, 5, and 6. So you'll notice in each row across, I keep the first die the same, and I let the second die roll through the values 1 through 6. And our sample space has a total of 36 equally likely outcomes. So once we have the sample space, and I would go ahead and write this guy down for yourself. You might pause. You should practice just generating it on your own. It's good to practice the generation of these sample spaces because then it allows you to answer the questions that follow. And really, I wouldn't want to try to do this next part without the sample space. So I could ask a bunch of questions. So again, if you want to pause, these are the questions I'm going to work on. And if you want to write them down for taking notes, that would be good, but we'll do them one at a time. So when I do probabilities, I want to be careful to observe the notation. It's one of the things that I like to grade for. So if I'm grading this on an exam, for example, I might have a short answer problem where you put both the notation for the probability and the result in, and they're both worth points. So you get points for the notation and points for the result. Okay, so the first one says, find the following probabilities. The probability of rolling 2 5s. So the notation would be the probability of 2 5s. I use sort of functional notation. We say with this capital P, the probability, and the probability of what? Probability I'm going to roll 2 5s. So I can look over in the table and figure out where we have 2 5s. Well, that's just right in here. And there's only one chance of getting 2 5s. So that's 1 out of the total number of chances, 36. I can leave that as a fraction. I'm fine with that for if we have an exam or worksheets, whatever. In the homework WAMAP, they're going to either want you to reduce it, which 136 is already reduced, or change it to a decimal, and then round accordingly on the homework to whatever it says to round to. So the probability of rolling 2 5s is 1 out of 36. The next problem says, what's the probability of rolling 2 even numbers? So 2 even numbers, probability that both rolls are even. And again, I'm going to look back at the sample space. In my sample space, this whole first column has the second roll being odd, so they can't both be even if the second roll is odd. So I can ignore the first, third, and fifth columns here because they have a die that's odd. And then back over here, there's both even, there's both even, and there's both even. So there's 3. And then skip the third row, 2 and 4 are both even, 4 and 4 are both even, 6 and 4, there's 3 more. I'm just counting them up. And then in the last column, 2, 6, 4, 6, 6, 6. There's 3 more. So it's a total of 9 out of 36. And if I were entering this as a fraction, I would want to reduce it down to 1/4, or if I'm putting it as a decimal, 0.25. Next one, probability that the sum of the dice is 7. So notice the notation, it's a different thing inside. I'm not talking about both dice, I'm talking about the sum of the two dice being 7. So I have the probability notation P of the parentheses, the sum is 7. So if you look at the sample space, my cat is trying to join us. Okay, here he is. This is Rio. Hi. Yeah, he's gonna go over there. Sorry about that. If you look at the sample space, it's gonna be all these guys in this diagonal. 6 and 1 is 7, 5 and 2, 4 and 3, 3 and 4, 2 and 5, 1 and 6. So this whole entire diagonal up the middle has values that add to 7, and that's the only place they are. And there are 6 of them. So the probability that the sum is 7 is 6 out of 36, or I could write that as a decimal, or I could write it as a reduced fraction 1/6, and then estimate it as a decimal as well. The next one says the probability that the sum of the dice is 1. Go to our sample space again, and if you've marked on your sample space, sometimes it's easier to get a new one. I have a fresh one each time, but so it's good not to cross things out, because you may need to use the sample space for more than one thing, like this problem. So the probability that the sum of the dice is 1, well, the smallest sum can be is 1 and 1, where both dice are 1, but that sum is 2. So you're never going to get a sum of 1, so that probability is 0. I mean, you could say 0 out of 36, but 0 out of 36 still equals 0. Next one, the probability of rolling doubles. So both dice are the same. I'm going to write probability of doubles. And again, the up diagonal had sums that added to 7. The down diagonal here, starting with this 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. Oh, I'm getting better with the pen. Sorry. Thanks. The down diagonal has the doubles, and again, there are 6 of them. So 6 out of 36. And I could again write 1/6, or reduce it down to decimal, 0.1667. If I'm rounding that to 2 decimal places in WAMAP, that would be 0.17. Maybe I'll just comment to here that it's rounded to 2 decimal places. Just initial that so it doesn't get too crowded. And you want to check when you're doing the homework in WAMAP that you are reading carefully what it says to round to, because it's a drag to miss a chance when you did everything right but you rounded incorrectly. I can also adjust those scores, so if you have a problem with a rounding error, you can just message me within the WAMAP problem, I think, or message. I think the easiest way is within the problem, or you can contact me on Canvas, let me know which assignment and which problem, and I can look at it. And I can see your past answers, so if you entered something in incorrectly, I can always adjust those. Okay, going back. Probability the sum is 5, given that the first die is less than 3. So this is a conditional probability. And a conditional probability, maybe I'll use a little more space here. What I like to do is if I can do it without the formula, it's usually better. And that's true for most probabilities. So set up a fraction bar here. The thing that happens first is that the first die is less than 3. So how many of those first die of how many total options have the first die less than 3? So I go back to my sample space. The first die would have to be a 1 or a 2 if it's going to be less than 3. So there are 12 options less than 3. And then we say sort of those, out of those 12. So now I'm only looking at the red stuff. Out of those 12, how many have a sum of 5? Well, 1 and 4 would be 5. Let's make it, I don't know, purple. And 2 and 3 would be 5. And so that would be, I'm looking for a purple pen, but I don't see one here. That's right, there we go, purple. That would be 2 out of 12. 2 out of 12. Equals 2 out of 12, which is equal to, again, 0.1667. So again, when you do the conditional probability, the notation is important. That's this bar in the middle. That's what replaces the word given. And when I read this, I say the probability, the sum is 5, given that the first die is less than 3. We figure out how many of the outcomes have a first die less than 3. That was 12. And then we say, of those, how many have a sum of 5? Good. Going on, the next one is also conditional probability. The probability the second die is 4, given that the first die is 4. So now I want the second die to be 4. So that notation is second die is a 4. The given, I use a vertical bar, given that the first die is 4. So what happens first? The first thing that happens is that the first die is 4. That's the thing that happens first. We want to know what's the probability the second die is 4 if we know the first die is also 4. So now, again, I set up a fraction bar, and I look at the thing that happened first, which is that the first die was a 4. Maybe. So how many have, so I set up my fraction bar and I do the denominator first. How many options had a first die of 4? That's over here. 1, 2, 3, 4, 5, 6 of these guys have a 4 first. It's downstairs. And then of those, how many of them have the second die also being 4? Well, it's just this one. Oops, not 2. Just the 1. Also, just a comment, I put all of my combinations in parentheses. When I first did the sample space, that just lists them sort of as ordered pairs or as points. It's just easier to organize and keep them separate from each other. So again, that is going to be 2 out of 6. No, sorry, 1 out of 6, right? Because we only have one of the original options out of the 6 that has a second die of 4. Okay. And again, I could come down here and say, okay, that equals 1/6. 0.16667. Okay, two more problems. The first one involves the word or, probability of rolling a 5 first or a 2 second. Again, both parts H and I could use the formulas that they talk about for and or in the book, but once we have the sample space, it's usually better just to figure out how many have a first die of 5 or a second die of 2. And you don't have to count the things twice. So what I'm going to do is first highlight all the ones where the first die is a 5. And there are 6 of them right there. And then I'm going to highlight all of the ones where the second die is a 2, and that's this column here. And there are 6 of those as well, but if you count now how many outcomes total I've highlighted red, there are actually only 11. So the formula that's given in the book, they say, okay, add the 6, add 6 more, 6 and 6 is 12, but don't count the 1 twice, so take the 1 away. 6 plus 6 is 12, minus 1 is 11. You know, we just don't have to count that 1 twice, so I'll just count everything once, and there are 11 things highlighted out of 36. 30%, 31% probability that would happen. Sometimes in WAMAP it'll say round your answer to the nearest percent. So this one would be, if I wanted to round it to the nearest percent, I'll show you how to do that. This would be 31% to the nearest percent. So you have to be careful whether it says round to a decimal, round to a percent, etc. Okay, last problem. Probability of rolling a 5 first and a 1 second. So this one was an or. Now I'm going to do an and. And that is part of my notation. So I want to highlight, you know, I'm capitalizing the words and or there so that we make sure that we're emphasizing it. Okay, so we have a 5 first and second die is a 1. Well, if I look at the sample space, how many total outcomes have a 5 first and a 1 second? There's really only 1 right here. So that is the answer, 1 out of 36. And I think that is the easiest way to do the problem. Another way to sort of think about it, and that guy would be done. Another way to think about it, I'll go to the next page here, would be, I'll just leave it on here, would be to think about, okay, all the 5s first, red, all the ones with 1 second, also red, and then where is the overlap? It'd be this guy, which I'll make, you know, purple. So if I just did the overlap, and is the overlap only, so that would be 1 out of 36. Make that purple. So that's finishing this example. I'm going to go back and do the same thing with the or. So the and means only the overlap. The or means all of both. So or means all of both sets. So in this example, we would have all of the ones where the 5 is first, along with all of the ones where the 2 is first, and then I'll just put here in parentheses, no need to count middle, the overlap, twice. So if you don't count the overlap twice, then you don't have to subtract it off. And we don't have to use, if you'll notice, for this entire problem, I didn't use any formulas. I just used the logic of, I have this sample space, and I used good notation to identify what I was looking for, and then I just figured out how many of the 36 options had the outcome that I was looking for. The only exception to 36 is when you're looking at the conditional probabilities, F and G. They have the word given in them usually. And then that lowers the number of possibilities to however many chances the second thing here happens, or the thing that went first. How many of the first dies are less than 3? There were 12. How many of the first die is 4? There were only 6. So that limits the number of possibilities. And then numerator is computed by saying, of those, how many also had that second condition. Okay, so that's an example for rolling 2 dice and primarily doing it by generating a sample space. There's sort of another sample space that we typically generate, and that's like flipping a coin either 2 or 3 times. So do that example as well. Then you can break these probability problems down into a couple different types. There'd be sort of the type of problem where putting marbles in a hat and taking out a certain number of marbles either with or without replacement. These are sort of games of chance, rolling a die, flipping a coin. There's problems involving tables. So I give you a table and we read from the table who satisfies the probability that we're looking for. And then finally, there are problems with sort of percents or a Venn diagram. And we usually fill in the diagram first, and then we figure out what probabilities we're looking for. Okay, so I have examples for each of these. I'm going to work through them, and hopefully that you will find them helpful. All right,